Using the normal distribution to model returns assumes that outcomes scatter symmetrically around an average. The tails of the normal distribution are light. Events far from the mean are assigned very small probabilities. This assumption simplifies risk calculation, but encodes a structural choice that must be justified. The Gaussian model is fully determined by two parameters. One locates the center of the distribution, the other measures the typical scale of deviations. Together they describe a bell-shaped density that assigns most probability mass near the mean. A process drawn from a normal distribution stays inside its sigma bands most of the time. It appears stable, its typical excursions are bounded and symmetric, no single observation dominates the trajectory. Two processes can share the same mean and standard deviation while generating fundamentally different extreme events. The normal process rarely leaves the sigma band. The heavy-tailed process does not. The model cannot distinguish them from those two parameters alone. The normal shape emerges when contributions are independent, identically distributed, and no single term dominates. When observations are dependent, or one contribution is much larger than the rest, the limiting shape is no longer normal. The conditions of the theorem matter as much as the theorem itself. The normal distribution is not a universal law. It is an approximation whose accuracy depends on whether the conditions that generate it are satisfied. It fails silently when those conditions are violated. Its tail predictions are the first to break.